All right, so we have been talking about adding and subtracting involving inequalities, so we're going to move on to multiplying and dividing. So our goals today is that we are going to solve inequalities by multiplying or dividing by a positive number and by a negative number. There is a difference in how we deal with those, so we'll talk about that in a second. First, we're just going to do a little review problem to get our brains going. So there are at most 36 red and blue marbles in a bag. So before I even read any more of that, I know this is an inequality problem. And so when I see these words at most, that says something in my head of like, oh, I know that this is an inequality. When I read the words at most, that means that whatever I have on my left-hand side is going to be less than or equal to 36. So I'm just going to start there, knowing that eventually I'm going to get to that point. So the number of red marbles I know is twice the number of blue marbles. So I'm going to write and solve an inequality that represents the greatest number of marbles in the bag, red marbles in the bag. So if I look at the relationship between red marbles and blue marbles, I know that there's twice as many red ones as there are blue ones. So I'm going to have 2r plus b, so double my red plus my blue ones is going to have to be less than or equal to 36. So if I'm going to solve for r, I would need to subtract b from both sides. Got 2r is less than or equal to 36 minus b. I would just divide both sides by 2. Gives me r is less than or equal to 36 minus b over 2. That is my solution. R needs to be less than those things. Okay? So, now diving into our actual material today. Solving inequalities by multiplying or dividing by a positive number. When we divide or multiply by a positive number, it will not change the direction of our sign in the inequality. So it's the same as like when we're adding or subtracting in dealing with inequalities. It's not going to change my direction of the sign. So I've got negative 4 is greater than x divided by 4. I'm going to multiply both sides by 4. Gives me negative 16 is greater than x. Now, this is the part where people have gotten a little bit confused. Okay, so when I go to graph this, a lot of people would intuitively say, well, this is a greater than sign, my arrow needs to point to the right. But that's not what's happening here. So I can rewrite this with my x on the left-hand side, but if I rewrite this with my x on the left-hand side, then I need to flip my sign. So negative 16 is greater than x is the same thing as saying that x is less than negative 16. These are the two statements are equivalent. They're the same. They're just written in a different way. So my actual one, if I'm going to graph it, is that x is less than negative 16. So if I go down to my graph, maybe I'll put negative 16 right here. So then I've got negative 14-ish here, negative 12, negative 10. Oops. I was doing this earlier today too. Negative 16. Oops. Negative 18. There we go. Negative 20. Negative 22. That would be negative 14. All right, so then I've got x is less than negative 16, which means that I'm going to have an open dot on 16, negative 16. It's less than negative 16, so my arrow will point to the left. There's my arrow. It's underneath, but that's okay. My arrow is pointing to the left. All right, our next one, 2n is greater than or equal to negative 14. Now divide both sides by, just by 2. Divide that by 2. I'm left with n.
Mr. Slack, you have a call on line 1. Mr. Slack, line 1.
N is greater than, greater than or equal to negative 7. I don't have to rearrange anything because this isn't a format that I like. It will work for me. So now I just need to come down here and graph. So it's a greater than sign, which means I know it's going to go to the right. So I'm going to start my -7 here. -5, -3, -1, -9. It's greater than or equal to, so I know that it's going to be a closed dot on -7. It's going to go to the right and is greater than -7. That should all be pretty straightforward. It's very similar to when we just used equal signs. Now we just have inequalities that we're using instead. Where it gets a little trickier is when we are dividing by negative numbers. So let's look at this. When we are dividing or multiplying by a negative number, it will change the direction of our sign in an inequality. So I'm going to start with the second one first, actually. So I've got -5m is greater than or equal to -45. So in order to solve this, I need to divide both sides by -5. Since I'm dividing by a negative number, that means that I need to flip my sign. So this is going to change to m is less than or equal to -45 divided by -5 is 9. M is less than or equal to 9. So when I graph this, I'll have 9, whoops, nine, 11, 7, 5, 3. Less than or equal to means that I'm including 9, so I'm going to do a closed dot at 9. Less than or equal to means that I have my arrow pointing to the left. M is less than or equal to 9. Okay, and the reason why I want to do this one second is because it's a little bit more complicated. So I've got 3 is greater than -x divided by 7. So if I want to get x by itself and I want x to be positive, I'm going to multiply both sides by -7. Multiply by -7 means that I have -21. My sign's going to flip because I'm multiplying by a negative number. So 21 is less than x. -21 is less than x. Now, this is where it gets a little bit confusing because remember, if I have my variable on the left-hand side, it's a little bit more intuitive of what I'm going to do with my graph, right? Because if I look at this right now, -21 is less than x. I would think that my arrow needs to be pointing to the left because it's less than. But that's not the case here, right? So if I'm going to rewrite this, I would rewrite it as x is greater than -21. And the reason why people have been a little bit confused about this today is because, well, Mrs. Olson, you said that when we multiply or divide by a negative number, our sign will change. But my sign here was a greater than, and now my sign over here is a greater than. And yes, that is true, but notice from this step to this step, right, our sign changed. The reason why we flipped it back was because we moved our x to the left-hand side. So when I moved my x to my left-hand side, I needed to change my sign to reflect that change. So now when I'm graphing this, I know that x is greater than -21. So I'm going to do -21 here, -19, -17, and so on. I'm going to have an open dot on -21. My line is going to point to the right. X is greater than -21. Okay, last one down here. A real life example. So you earn $8.50 an hour to work at the sub shop. We're going to write and solve an inequality that represents the number of hours you need to work to earn $187 to buy a year's supply of Sour Patch Kids. So if we're going to set this up, I've got $8.50. I'm just going to represent that as 8.5, $8.50 per hour. So per hour means that I need to take 850 times however many hours. So 850 per hour. And it needs to be at least, we need it to be at least $187. When I see the words at least, that means that my x needs to be greater than or equal to 187. So then in order to solve this, I'm just going to divide both sides by 8.5. And then I'm left with x is greater than or equal to 187 divided by 8.5 ends up being 22. So I need to work at least 22 hours to make $187. Okay, the rest of this packet, this note sheet then, is just some practice for you. So I've got 2.1 practice on the front. That's all about adding and subtracting inequalities. So like this first one, when I have sentences like this, I think it's helpful to write things out as I read them. So right here I have a number x plus 10. Well, that's just going to be, it's literally just going to be, okay, we're going to go over here. X plus 10, right? I've got a number x plus 10 is more than, stop, is more than, which means it's greater than, 2. X plus 10 is greater than 2. So you're going to go through and create an inequality for each of these. You don't have to solve them. I'm just asking you to write them. Numbers 5 and 6, you are just plugging in this value to see whether or not the solution is an inequality, or is a solution to the inequality. So for number 5, I've got t equals negative 6. T equals negative 6. So I'm taking my t equals negative 6, plugging it into my equation, and seeing whether or not it's true. So this is either going to be a no, it's going to be a yes or no answer. So decide if it is or it is not. And then 7 through 10 down here, you are solving the inequality and then graphing it. So solve it how we know that we need to solve it, and then graph it. The one thing that I'm going to note here is number 10. Okay, so I have w minus a negative 4 is less than 8. I know that when I subtract a negative, it makes it positive, right? So I can rewrite this as w plus 4 is less than 8. That's the same thing. So then solve it from there. I think you can do that. On the back side then, I have some multiplying and dividing of negative numbers. So 1 through 6, you're just multiplying and dividing. Oh, I should have said 1 through 8. I didn't change that. So that's 1 through 8. You're doing 8 problems. And then there is one word problem at the bottom. Remember, whoops, come on, stop. Remember that when we multiply or divide by a negative number, our inequality sign flips. Just when it's a negative number. Just negatives. So go ahead and finish that up, and then we are done with this one for today.